Welcome to the new session of the course of differential equation. In this session, we will discuss about the method of variation of parameters. This is also a method to solve non-homogeneous linear differential equation. We consider a differential equation of the form y double dash plus p of x y dash plus q of x y is equal to some g of x. Here g of x is the non-homogeneous part. Say this is the second order linear non-homogeneous differential equation. Here this one this p of x and q of x and g of x are the these three are the functions in x or this one constants, functions in x or the constant values. Okay. See, we already discussed about the method of undetermined coefficients. So, that have some limitation. So, on that case we can find the solution based on the value of r of x, that r of x may have any of this form exponential or polynomial or trigonometric or their products, okay, and their sum also. But in this case we have a more general formula. By using that one we can solve many kind of the non-homogeneous differential equation like this. See, dear students, here suppose consider we have the corresponding homogeneous part, that is the corresponding homogeneous part as corresponding homogeneous part as y double dash plus p of x y dash plus q of x y is equal to 0. This is would like to say this is equation number 2. So, simply we can solve this equation. We already discussed many methods to solve second order homogeneous equation. By using any of that methods we can solve this second order homogeneous equation. So, definitely it will have a this one yh is equal to C1 y1 of x plus C2 y2 of x. Okay, fine. So, this y1 of x and y2 of x are the complementary solutions of the homogeneous part. So, y1 is one of the solution and y2 is another solution. So, for this method of variation of parameters, we can have a formula that is equal to we need to find, as we said before, discussed before, the general solution of given non-homogeneous equation 1 as, that is y is equal to yh plus yp. Y is equal to yh plus yp. So, we already found the yh, we are able to find the yh by using the many methods that we discussed before to solve homogeneous equation, and here we have to find yp. Okay. To find yp, here we are using a formula for the method of variation of parameters. To find yp, we use the formula yp is actually equal to minus y1 of x into integral y2 of x into g of x divided by, where g of x is the corresponding non-homogeneous part, it is a function in x alone. Therefore, we can say that this is equal to g of x divided by Wronskian of y1 y2 of x into dx plus this is y2 into integral of y1 of x into g of x divided by Wronskian of y1 y2 of x dx. See, dear students, this is the actual formula. By using this we can find a value of yp. Okay. Say here we have we already discussed here, this is equal to here y1 and y2 are the solutions of homogeneous equation. Here y1 and y2 are the independent solutions of homogeneous part, homogeneous equation, that is y double dash plus p of x y dash plus q of x is equal, sorry, p of x y dash plus q of x y is equal to 0. Y double dash plus p of x y dash plus q of x y is equal to 0. Okay. P of x y dash plus q of x y is equal to 0. See, we have Wronskian. Wronskian is actually Wronskian of W is actually Wronskian of y1 y2. Wronskian of y1 y2 is equal to determinant of, that is we have this is y1 y2 y1 dash and y2 dash. Okay. This is equal to we can say that actually this is equal to y1 into y2 dash minus y1 dash into y2. Okay, fine, minus y1 dash into y2. Okay. So, simply suppose if we have a non-homogeneous equation like this, we are able to find out the solution of the homogeneous equation, that is from there we will get the independent solution functions that are the form a basis for the homogeneous differential equation. So, from there we have y1 and y2 is there, we need to find the yp, the particular solution for the non-homogeneous equation. So, for that we use this formula, that is equal to minus y1 into integral of y2 into g of x divided by Wronskian dx plus y2 into integral of y1 into g of x divided by Wronskian dx. Okay. Where Wronskian we can find by using this formula, and this is y1 and y2 are the independent solutions of the homogeneous parts. Okay. Based on that we can solve this problem maybe sometimes. So, therefore, we will have this is equal to, therefore, general solution of given non-homogeneous equation 1 as y is equal to, that is equal to c1 y1 of x plus c2 y2 of x plus yp of x, that we will determine by using that formula. See, maybe sometimes while doing the with the problem, maybe this one, if the equation as f of x y double dash plus g of x y dash plus q of x y is equal to some r of x, okay, or g of x, r of x, or simply g of x. Okay. This is also non-homogeneous differential equation. Okay. This is sorry f of x, we already used here one more g of x. See, I would like to say this is equal to r of x. Okay, fine. See, here we have the function, but sorry, differential equation is there, but that is not in the form of the standard form that we discussed here. So, here y double dash is alone. So, here see if f of x not equal to 0, if f of x is equal to 0, there is no discussion, the differential equation will be the first order. So, our discussion is based on the second order, the f of x definitely non-zero function. Okay. So, we divide throughout with the f of x. So, I would like to say this is the equation number 3. In equation number 3, we will divide 3 with f x. Therefore, we will have the differential equation as y double dash plus g of x divided by f of x. If f x never be 0, then into y dash plus qx divided by fx into y is equal to r of x divided by fx. Now, we convert it into standard form. So, here we can consider this as this is equal to that as previously we discussed p of x like that is a function in function in x, and this as small q of x and this as small g of x. So, we converted that into standard form that we need to solve. So, if this is in the form of if y double dash with y double dash have any functions, there have any functions in x, we will do like this, and then we convert the function differential equation into this form as in equation 1, and then we will use we will find the solution of the corresponding homogeneous equation, and then we will find yp by using this formula. Okay. Okay, dear students, I would like to invite your attention to the next question example. See, in this example we discuss solve the differential equation, solve the non-homogeneous differential equation by the method of variation of parameters, by the method of variation of parameters. See, the equation as y double dash plus y is equal to sec x. This is our equation 1, y double dash plus y is equal to sec x. See, here we have to solve this equation by using the method of variation of parameters. So, firstly we can consider the homogeneous part, that homogeneous part as y double dash plus y is equal to 0. Okay, find the corresponding auxiliary equation is see, what about the auxiliary equation? M square plus 1 is equal to 0. Okay, fine. So, we can have this, we can take this 1 to here, therefore, m square is equal to minus 1. So, m is equal to plus or minus I. So, the roots are complex, they are the complex conjugate with the real part is equal to 0. With the real part is equal to 0, therefore, the general solution of homogeneous, therefore, general solution of homogeneous part, homogeneous part is actually yh is equal to e raised to, that is 0x a cos, that is the qx is the coefficient of I, is the imaginary part is equal to 1. Therefore, we will have a cos x plus b sin x, a cos x plus b sin x is there. That is yh is equal to a cos x plus b sin x, a cos x plus b sin x. See, this is equal to this is the first function, that is I would like to say this is y1 and this sin x is actually y2. Okay. So, we have y1 is equal to cos x and y2 is equal to sin x. Now, we have to find the Wronskian. So, the Wronskian of y1 y2, therefore, Wronskian of y1 y2 is equal to determinant of y1 y2 y1 dash y2 dash. Okay. y1 is equal to cos x, y2 is equal to sin x. See, dear students, therefore, Wronskian of y1 y2 is equal to, that is Wronskian of y1 y2 is equal to y1 is actually cos x, y2 is sin x, cos x sin x, y2 is sin x, derivative of cos x minus sin x, derivative of sin x cos x is there. Okay. While evaluating this, we can while evaluating this determinant, we have cos x into cos x, that is equal to cos square of x, is equal to cos square of x minus sin x into sin x, sin square x, and one more minus is here, minus and minus, plus sin square x is. So, we found the value of Wronskian is equal to 1. So, now we found the Wronskian is equal to 1. We have Wronskian W of y1 y2, Wronskian of y1 y2 is equal to 1, and y1 of x is equal to cos x, and y2 of x is equal to sin x. Y1 of x is equal to cos x, and y2 of x is equal to sin x. Fine. Now, we can apply in formula. So, to find yp, we have the formula. To find yp, see, to find yp, we have the formula. It is that yp is equal to yp is equal to minus y1 into integral of y2 into g of x divided by w of y1 y2 dx plus y2 into integral y1 of x into g of x divided by w of y1 y2 of x dx. Fine. So, compact, what is actually g of x? Okay. G of x is sec x. Okay. Fine. The sec x is here. So, to find, therefore, yp is equal to, that is minus y1 minus cos x, y1 is actually cos x and y2 is sin x. Here we have g of x is equal to sec x. Okay. G of x is equal to sec x. Fine. So, minus cos x in integral of y2, y2 is actually the sin x, y2 is actually sin x, sorry, y2 is actually sin x into g of x is sec x into sec x divided by Wronskian is equal to 1 into dx plus y2 is equal to sin x into sin x into integral of y1 of x is actually the cos x. Okay. Cos x into g of x is sec x, sorry, g of x is sec x divided by Wronskian is actually 1. Wronskian is actually 1, actually 1 dx. Fine. So, dear students, here we have yp is equal to minus cos x into integral of integral of sin x divided by integral of sin x divided by cos x is there dx plus sin x into integral of cos x divided by cos x, that is integral of 1 dx. Okay, fine. Cos x is here whose derivative is equal to minus sin x. Okay, fine. See, put u is equal to cos x, du is equal to derivative of cos x is minus sin x dx. Therefore, minus du is equal to sin x dx, sorry, sin x dx. Maybe for just a substitution that is not much enough, directly we can do, no problem. Okay. So, minus cos x into minus du by u, that is minus cos x, yp is equal to minus cos x into integral of, that is equal to sin x dx. Sin x dx is minus du, the cos x is u, therefore minus du divided by u, and finally see here we have this is equal to sin x into integral of 1 x sin x, that is equal to plus x sin x is there, okay, plus x sin x is there, okay, fine, x sin x is there. So, okay, fine, now we have this one cos x minus cos x into, therefore, this is equal to minus cos x into is equal to minus cos x into integral of minus log mod u plus x sin x is here, plus x sin x is here. So, we have this is equal to we can replace u as minus cos x into minus log mod, that minus and this minus will be plus cos x into, see this is equal to cos x into, so we can remove this and this is equal to cos x into log mod u, we can replace u by cos x, therefore log mod cos x plus x sin x plus x sin x. This is actually yp. Now we determined our yp, now we determined yp. See, this is yp. So, fine, yp is equal to cos x plus log mod cos x plus x sin x is here. Now, see here we have this is yh, we found yh as, see yh is equal to a cos x plus b sin x is here. Okay. So, therefore, general solution, general solution of given, therefore, general solution of given non-homogeneous differential equation is, general solution of given non-homogeneous differential equation is y is equal to yh plus yp, yh plus yp. Therefore, y is equal to yh is equal to a cos x plus b sin x. Now, again we have this is the yp cos x into log mod cos x. So, plus cos x into log mod, sorry, cos x into log mod cos x, cos x into log mod cos x plus, and again we have here it is equal to x sin x is there, fine. So, this is equal to plus x sin x plus x sin x, fine. We can just again can rearrange this as cos x into a plus log mod cos x, log mod cos x plus sin x into sin x into, again this is equal to sin x into b plus x, b plus x. Sin x into b plus x, fine. This is actually the general solution of the given differential equation. See, my dear students, you can have many questions can by using this we can solve many questions from this way. Generally, even some questions that we discussed before this can solve using method of undetermined coefficients, that also can solve by using this concept also. Okay. See, actually what we did it is there, we have non-homogeneous linear differential equation is there, we just found the auxiliary equation, sorry, we just finding, firstly we find the solution of the homogeneous equation. See here we have y double dash plus y is equal to 0 and the auxiliary equation is actually m square plus 1 is equal to 0. So, we got m is equal to plus or minus I. So, that m is equal to plus or minus I means that is actually the roots of auxiliary equation are the complex conjugate with the real part is equal to 0. So, that we found this is equal to y h is equal to a cos x plus b sin x, cos x is the y 1 and sin x is y 2. We can find the Wronskian by using this determinant. So, we found Wronskian is equal to 1 and now we found Wronskian is equal to 1, y 1 is equal to cos x, y 2 is equal to sin x and the g of x, or sometimes we use the r of x instead of g of x, maybe sometimes we used r of x also, that is the non-homogeneous part, that is the function in the RHS. So, that is sec x. So, we can use this formula y p is equal to minus y 1 integral of y 2 g of x divided by Wronskian into dx plus y 2 into y 1 g of x divided by Wronskian into dx. So, we just applied all those things. After integrating that, we found actually what is y p. Now, we have the general form solution of the given non-homogeneous differential equation is y is actually y h plus y p. So, y is equal to a cos x plus b sin x plus cos x into log mod cos x plus x sin x is here. We just rearrange it here. Now, this is the general solution of the given non-homogeneous differential equation. See, dear students, I would like to write one more questions to you. We just move to example 2. In example 2, we just discuss it is that find the solution of solve by method of variation of parameters, solve by method of variation of parameters d square plus 4d plus 4 into y is equal to e raised to minus 2t divided by t square, e raised to minus 2t divided by t square. This is our non-homogeneous equation, e raised to minus 2t divided by t square is there. See, dear students, this is this half the homogeneous part is here. So, while solving this, we will have as part of the solution, this is equal to this is the non-homo, this is for the homogeneous part. We have auxiliary equation as auxiliary equation for homogeneous part is actually auxiliary equation is actually m square plus 4m plus 4 is equal to 0. Okay, fine. Now, this is actually m square, m plus 2 whole square, this is actually m plus 2 whole square is equal to 0. Therefore, there exists a double root m1 equal to m2 is equal to minus 2 is the actually the auxiliary equation as a double root. Now, we are able to find the general solution for the homogeneous part. Therefore, general solution of homogeneous equation, homogeneous equation is actually y h is equal to, that is equal to c1 plus c2 x e raised to minus 2 x, because this is equal to m1 equal to m2 is equal to minus 2. Fine, we found this is equal to, therefore, from here we can say that the y1 is equal to, that is equal to e raised to minus 2 x, y2 is equal to x e raised to minus 2 x. Okay, fine, y1 is equal to e raised to minus 2 x, y2 is equal to x e raised to minus 2 x. Fine. Now, by using this, firstly we need to find the Wronskian. Okay, we just to find w, to find W, that is the Wronskian, to find W, the Wronskian. W is equal to is actually y1 y2, y1 dash and y2 dash is there. Okay, that is equal to that is equal to W is equal to y1 is actually e raised to minus 2x, y2 is equal to x e raised to minus 2x, e raised to 2x, x e raised to minus 2, e raised to minus 2x and x e raised to minus 2x is there. Derivative, we have the derivative of y1, that is equal to minus 2 e raised to minus 2x, minus 2 e raised to minus 2x, and the y2 dash, we have to find the y2 dash, that is equal to, we just consider x as a first function, this as the e raised to minus 2x as the second function. So, we have this is equal to x into minus 2 into e raised to minus 2x plus e raised to minus 2x. Okay. So, we have this is equal to Wronskian, while multiplying with this, we will have this is equal to e raised to minus 2x, x e raised to minus 2x, minus 2 e raised to minus 2x. So, 1 minus 2x into e raised to minus 2x. Okay, fine. Now, we can find the Wronskian. The Wronskian is actually this is equal to e raised to minus 2x into 1 minus 2x, that is equal to 1 minus 2x into e raised to minus 2x into e raised to minus 2x. That means e raised to minus 4x minus 2 into x into minus 2 into, again we have minus minus, negative sign is there, therefore, plus 2 into x into e raised to minus 2x into e raised to minus 2x is there. Sorry, e raised to minus 2x into e raised to minus 2x, therefore, e raised to minus 4x is there. Fine. So, we will have minus 2x e raised to minus 4x plus 2x e raised to minus 4x. So, we can cancel both these two. So, we will have this is this we can cancel, and finally, here we will have e raised to minus 4x into 1 is here. So, we have the actual answer is equal to e raised to minus 4x. So, that is Wronskian, we found the Wronskian. So, we have y1 is equal to e raised to minus 2x and y2 is equal to x e raised to minus 2x, and Wronskian w is equal to e raised to minus 4x, and g of x is equal to, we have g of x is equal to. So, come back to the solution, e raised to minus, sorry, instead of t I just like to replace this as x. Okay. Sorry, e raised to minus 2x divided by this one is actually the value is equal to, fine, that is equal to x square, minus 2x divided by x square. Okay, fine, this is equal to x square is here. Fine. So, therefore, this is actually g of x, this is actually g of x. So, g of x is equal to e raised to minus 2x divided by x square. Okay. G of x is equal to e raised to minus 2x divided by x square. Fine. Okay. Now, we can use the formula, therefore, to find yp, to find yp, to find yp, to find yp. So, we can use the formula as, that is yp is equal to minus y1, that is minus y1 into integral of y2 into g of x divided by Wronskian into dx plus in y2 into integral of y1 into g of x divided by Wronskian into dx. Okay, fine. Now see, we have minus y1, that is the y1 is actually minus e raised to minus 2x, sorry, e raised to minus 2x in integral y2 x e raised to minus 2x, x e raised to minus 2x, and then g of x is equal to, sorry, x e raised to minus 2x into g of x is equal to e raised to minus 2x divided by x square, and whole divided by the Wronskian is actually e raised to minus 4x. So, this is equal to e raised to minus 4x, okay, into dx plus y2. y2 is actually x e raised to minus 2x into integral of y1 is e raised to minus 2x, and g of x is equal to e raised to minus 2x divided by x square into the Wronskian is e raised to minus 4x. Wronskian is e raised to minus 4x. Fine, dx is there. Okay, we can cancel the terms of e raised to minus 2x, e raised to minus 2x, and e raised to minus 4x is here. And also we can cancel from here e raised to minus 2x, e raised to minus 2x, and e raised to 4x is here. So, finally, we found e minus e raised to minus 2x. So, this is equal to minus e raised to minus 2x into integral of, see here we have the integral, we have 1 x is here, and we can cancel 1 x from here, sorry, 1 x from here and 1 x from here. So, 1 by x dx is here. So, we have this is the value, that is 1 pi x dx plus, and the next one is x e raised to minus 2x into 1 by integral of 1 by x square dx. So, x plus x e, sorry, plus x e raised to minus 2x into integral of 1 by x square dx, integral of 1 by x square dx is here. So, this is equal to minus e raised to minus 2x into integral of 1 by x, that is log mod x, log mod x plus x e raised to minus 2x into integral of x raised to minus 2, that is equal to x raised to minus 2 plus 1 divided by minus 2 plus 1. Okay, fine. Therefore, we have finally we have minus e raised to minus 2x into log mod x plus x e raised to minus 2x into this is x raised to minus 1, that is equal to, and minus 1 is here. Instead of that, I just replace this as with this minus sign. I just taking this minus sign to here, and here we have 1 by x is here. Again we can cancel this x and x. Here x raised to minus 1 and x raised to plus 1 is there. So, finally, we found this is equal to, that is e raised to minus 2x, that is the here we have negative sign as well as here also we have a negative sign. So, I took minus e raised to minus 2x into log mod x plus 1. Okay, fine, this is yp, this is actually yp. Now, we found yp, and also we already found this one yh is equal to c1 plus c2 x e raised to minus 2x. So, we have, so therefore, the general solution, therefore, general solution of given non-homogeneous differential equation is actually y is equal to yh plus yp, y is equal to yh plus yp, and that is y is equal to yh is equal to, that is equal to c1 plus c2 x e raised to minus 2x, c1 plus c2 x e raised to minus 2x, c1 plus c2 x e raised to minus 2x, and finally we found yp, sorry, yeah, we found yp as minus e raised to minus 2x into log mod x, minus e raised to minus 2x into log mod x plus 1. Okay, fine. Maybe if we need, we can take this one, e raised to minus 2x is out. So, this is enough. This is the general solution of given differential equation. If we need, we can take e raised to minus 2x is out, no problem. Okay, fine. So, by using this method, we can have solved the method of many of the non-homogeneous linear differential equation. See, my dear students, compare than the undetermined coefficients, this formula is very useful to solve many kinds of maybe some differential equation have very tedious to solve by using the method of undetermined coefficients. On that cases, we can use the method of variation of parameter. This is a very nice formula to solve non-homogeneous equation. Thank you for watching these videos. Continue watching. Thank you very much.